Here we go. So proportion of people who own cats. So the population is all people. Okay, I don't limit. I can't say the population is people with just cats because I'm looking at the proportion of people who have cats. So that means we need to know who has cats and who does not. So just for fun, identifying the population was a little tricky on last week's application. So the population here is all people. And we are trying to find parameter of that population. Parameter is some measurable characteristic. And that parameter is the proportion of people who own cats. And oh, just a reminder about these problems, Bruce and everybody else. If you do struggle, like you do it a few times, video's not helping, hit that message instruct you button so I get a note that says, I tried blah, 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 blah. And if you don't give me enough information, I'll probably reply back saying, hey, can you send me a picture of something you tried or something like that. So please don't spend an hour on one problem. Message me. All right, so since this is a proportion and not a mean, that means the parameter is labeled with a p. And we have to decide what is the null hypothesis for p and what is the alternative hypothesis for p. The null hypothesis has to have an equals in it somewhere and the alternative cannot. So test the claim that the proportion of people who own cats is larger than, so larger than to me means p is greater than, that symbol right there, larger than, greater than 0.5. Usually we state the proportion as a decimal in the hypotheses. Yeah, so that right there, because it does not have an equal to in its English math translation, then that has to be the alternative hypothesis. So since there's nothing else to go on, the null hypothesis would be an equal to 0.5, although some people would make it a less than or equal to. But that's optional and debatable. Okay, other thing we know is the significance level. So we're taking this very, very seriously. So alpha is the significance level, 0.005, which is 0.5%. And let's see, welcome Kelly and Jesus and Charlotte. Glad you can join us. Again, this is what we call the significance level. How important is it that we don't make a mistake rejecting the null hypothesis if it's actually true, is what the significance level attempts to put a boundary on. And it's an estimate of the probability that we can afford to make a type 1 error, is what I just described a second ago. Okay, so I got that part set up. So then I'm going to start my sketch here. And so anytime you start one of these problems, I expect you to define the parameter at least, if not the population, and the null and alternative hypothesis, and then start your sketch. So draw your best bell-shaped symmetric curve. In the middle, we put whatever the null hypothesis says, which is p is 0.5 or 50%. This right here, the greater than means I'm doing a right tail test, because I have reason to suspect the sample might come to the right of that, greater than. So I'm expecting my sample data to be somewhere out here. And that's what we, oops, I meant to switch color. There we go. So I'm expecting the sample data, that would be called p prime or p hat, to be out here somewhere. And so next we go and look up what the sample says and run it through StatKey. And then the question is, how far does p prime land from what we think p should be? If p prime lands way out to the right, then we say, oh, whoa, that's kind of far out. Something's interesting going on. Maybe this assumption about the null is incorrect. The significance level basically says how far out you have to draw your line in the sand to say what matters and what doesn't. So 0.05 means we're drawing a line in the sand way out here. And we're saying we're only concerned about samples that are in the upper 0.5%. So this is my significance level over here. And so we'll see where the sample data falls. Does it fall on that side? or will it fall on this side of that line in the sand? And the p-value helps us figure that out too. So there's lots of p's floating around here, so be careful. We have the population, the parameter, the proportion. We have that proportion for the population is p, the proportion for the sample is p prime, and then we have this thing called a p-value. Eek. Okay, so in StatKey, they tell me that the proportion in the sample of 300 was 51% of those 300 people did own cats. So the question is 51 significantly higher than 50 out of 300 people? And again, this is what a hypothesis test helps measure. When is far, far enough? So we jump into StatKey, and we are doing a hypothesis test for a proportion. Actually, choose the right one. And then we need to set the data. And this doesn't say grab a StatKey data set. We're given the data. And StatKey wants to know the count and the sample size. Well, I know the sample size is 300. And there's some numerator such that when I divide these two, I get 51%. So what's 51% of 300? That is 153, I think. Did that right? Yep, 51% over here is the proportion. Okay, so that's my sample. All right. Next thing I have to check is the null hypothesis correct? And this says p is equal to 0.5. 0.5 is 50%. That's what I wrote down in my notes, right? Yep, okay. So I got my data in there for a proportion. I have the null hypothesis set. I'm ready to generate thousands and thousands of other samples, each of size 300. So right now I have 6,000 samples, all of 300, 6,000 groups of 300 people, and each time there was a slightly different proportion of the number who said they owned cats, based on this original deck of cards up here in the original sample. We're doing a right tail test, and then we need to find the p-value. My tools for Zoom are in the way. Hang on, there we go. So we need to enter our data down here, and our data was 51%, so 0.51. So the process again is, if you want the p-value, you got to make sure you have the right data set. You got to make sure you have the right null hypothesis. You got to generate thousands and thousands of samples. Then you got to choose the right test. Once you do that, then you plug in the value, the statistic from your sample, and see what happens up here. So I'm getting a p-value of 38%, which is huge, which is common. Why 51, not 50? So that's a good question. Let me draw on this screen here. So what I'm about to explain, if I get Mindy's question right, is based on, I'm going to go back to the home page for a sec. Oops, wrong button. Maybe right button. Right button. Okay. I give a breakdown of how to use StatKey to do hypothesis tests. So that's in these models here. So I'm basically running through this right here with a different example. And so everything I'm describing right now is located in here with an example and pictures. Okay. This is a two-tail test, which is a bit harder. We could do one of those in a minute if you'd like. All right, so I want to label the StatKey. Oh, you think you get it now? I just want to explain that to everyone else because this is a common misconception. What am I doing? I need to go screenshot this, right? Yeah. So I just want to label some things on here. And I want the whole damn screen. Darn screen, sorry. New page, please. All right, so here's my StatKey. So the things we have to check out to make sure we get right is number one, do we have the right data? And for proportion, that means you need a count and a sample size, right? Data. So this right here is my data. So these two are kind of related. That's the first thing I gotta do. The second thing I gotta do is, do I have the right null hypothesis? Right, null. Okay. Once I'm sure I have the right data and null hypothesis, then my step 3 here is to generate thousands and thousands of samples. When that's done, I have to then choose the right test. Choose test. And then once I choose the test, I come down to the x-axis here, and step 5 is to plug in the sample statistic. Plug in sample statistic. In this case, that statistic is the proportion, but it could be a mean of a bunch of numbers that we measured. Once I have that, then step 6 here is to identify the p-value. Okay, and then from there I make my decision and write up my conclusion. All right, so again, it's the sample, the hypothesis, the null hypothesis has to go up here. The sample statistic has to go down here, always. So that's the order of operations in StatKey. So now, again, every time we do one of these, we're shuffling the deck, and slightly different things happen each time. So am I gonna get, if I run this again, am I gonna get exactly a p-value of 38.2 for exactly the same data? The answer is no. So I'm gonna reset and run it again just to see. Curious. And sometimes it comes out the same. It just kind of depends. 300 is a reasonably large sample, so it might come out exactly the same. I did a few more samples, 8,000 instead of 6,000. And then what do I want to do? I want right tail and sample data 0.51. 0.385. Before it was 0.382. They're in the ballpark of each other. With the computer, I tried to give it a reasonably wide window to accept the variability that comes from simulations, but every once in a while, a simulation pops up that was beyond what I expected. So if you think you did this right, then message me and send me a sketch of what you set up. So I would expect to get something like, back page, something like this right here, where you've also labeled your sample data. So for mine just now, eraser, my p-value ended up inside that line in the sand, which was 0.51. And so my p-value up here, p-value was about 0. I'll go with the first one, 382 was the p-value when I ran that test the first time. So I would expect to sketch something like this, saying, hey, this is what I tried, just take a picture of it, get me that picture, and anything else you think you need to know when you message me. So 0.382, that's a huge p-value, which means this sample's pretty damn close to what the null hypothesis said it should be. This sample supports that the proportion of people is around 50%. So we fail to reject the null hypothesis. The data is in support of the null hypothesis. And let's check all the boxes. This is a right-tailed, and I have a proportion where p is greater than, less than or equal to. That would be okay. That would not be okay, and that's not okay. Yeah, that's got to be it. Would it be possible to do 9? Sure. Let me submit this. All right, I got lucky. Bruce, did that help? Did it go any better? Did you try it again while I was doing it? Okay, cool. Do you have a suspicion now of what went wrong before, hopefully, that you know what to not repeat? Okay, cool. All right, so that's that one. I'm gonna stop